Hello again. My name is Jeff Harden, and today I have a brand new presentation for you. Today's presentation pertains to the topic of databases. That's what we have coming up today, so let's get started. Topics covered in today's presentation will include what is a database, types of databases, the two classifications of databases, examples of databases, advantages and disadvantages of each classification of database, and finally, a brief conclusion to wrap everything up. So let's start by defining what a database is and some types of databases. What is a database? Databases are a collection of information that is organized so that it can be easily accessed, managed, and updated. Databases can be as simple as an alphabetic arrangement of names or as complex as a database that provides information that is in a multitude of formats. Now let's discuss some of the various types of databases. Bibliographic databases are simply organized digital collections of references to published literature. These databases can include many forms of literature, including newspaper articles, journal articles, and government and legal proceedings. A full-text database is similar to a bibliographic database, except that it contains the complete text of the books, journals, and other literary publications that are contained within the database. An image database is exactly as it sounds. It is a collection of images ordered and organized in a specific way so that it can process queries into the database. An audio database is a collection of audio samples that are organized into a database format in order to make gathering these samples or information about them more efficient and streamlined. And combination databases are databases that house data in various formats, hence the name combination. All of these databases and the respective data would be rendered almost useless without database management systems. Database management systems are software for creating and managing databases. They provide a systematic way to create, retrieve, update, and manage data. They manage three very important things: the data, the database engine, and the database schema. These help provide concurrency, security, data integrity, and uniform administration procedures. Database management systems provide a centralized view of data that can be accessed by multiple users in multiple locations in a very controlled manner. Now I'd like to move into the two distinct classifications of databases. The first classification is called relational databases. Relational databases are formally defined as a collection of data items organized as a set of formally described tables from which data can be accessed or reassembled in many different ways without having to reorganize the database tables. The standard user and application program interface to a relational database is known as Structured Query Language, or SQL. And I will talk more about that on the next slide. Each table or relation in a relational database contains one or more data categories in columns, while each row on the table contains a unique piece of data for the categories designated by the columns. Because relational databases contain related data that is concisely organized, users have the ability to obtain a view of the database that is very specifically tailored to that user's needs. For example, a branch office manager might want a report that contains all customers who had purchased select products after a certain date. SQL. SQL is short for Standard Query Language. It is the special purpose programming language designed for managing data held in relational databases. It is used to modify database tables and index structures and retrieve subsets of information from within a database for various applications. SQL operations take the form of commands written as statements such as select, add, insert, update, and delete. SQL commands are divided into two different types of commands. The first type is data manipulation language, or DML, which is used to retrieve and manipulate data. And the second is called data definition language, or DDL, which is statements that define and modify database structures. Now moving on to non-relational or non-SQL databases. A non-SQL database provides a mechanism for storing and retrieving data which is modeled in means other than the tabular relations utilized in relational databases. This means that non-relational databases forego the table form of rows and columns in favor of a specialized framework to store the data. This form of data storage and organization is more suitable for loosely structured data than what is housed in relational databases. The most simple type of non-SQL database is known as key-value storage. It stores data in a completely schemaless way and has no defined structure that governs what is being stored. This makes these systems very easy to implement and add data to, allowing them to be utilized in storing data based on a key. Now I'm going to delve into a few examples of databases. The first example is a very popular relational database system known as Oracle. An Oracle database is a collection of data that is treated as one unit. It was the first database system to utilize SQL, as well as being the first database that was designed specifically for enterprise-grade computing, which is the most flexible and cost-effective way to manage information and applications. The next example I have for you is Microsoft SQL. Microsoft SQL is another very popular relational database. Its functions and purpose are very similar to Oracle, but it runs on Microsoft's SQL Server. It is another database service that is tailored to enterprise-level computing, but it has many versions available on the market, and each version has specs that are better for certain types of businesses and needs in order to ensure the proper fit to where the program is being implemented. The last example I have is called Mongo Database. Mongo Database is a non-relational database that was developed through open source programming. It strays away from the table-based structure of relational databases towards a structure with more dynamic schema. It allows for ad hoc queries, indexing, load balancing, file storing, data aggregation, and capped collections. Now let's go over some of the advantages and disadvantages of relational and non-relational databases. Starting with some advantages of SQL databases. These advantages include the elimination of duplicate data. They allow for easy access to information in one place. Multiple users can access the data from secure points with the proper credentials. And these databases are also very flexible, precise, and secure due to the SQL that is utilized to gather and organize the data that is stored within the database. Advantages of relational databases include that the data can sometimes be too complex for regular users to interpret properly. They often require powerful servers to host the database because of the sheer quantity of data housed within it. And this means that the databases are often expensive and can sometimes have broken keys or records that can prevent a user from accessing certain data. And now moving on to non-relational databases. Some advantages of non-relational databases include that they allow for transparent expansion, which means that the database is more easily scaled for adding or deleting data. They can handle large quantities of data due to their increased scalability. They supposedly have less maintenance and management because they are supposed to do all of this management themselves. However, for the time being, these systems still require human control for much of the maintenance and system monitoring. And these systems are also often very inexpensive, or free. Some disadvantages of non-relational databases include that there's a lack of support when compared to relational databases because relational databases are often run on the enterprise level, where companies pay large amounts of money to use the software and receive support if the software malfunctions. As stated earlier, these non-relational databases do require administration. This is because these systems are very new and still require some maintenance and changes in order to perfect the systems. Being brand new also means that there is a lack of expertise when it comes to non-relational databases. So in conclusion, databases are essential to business because they provide a sort of data container where a company can put its data and it can be organized and stored in a way that is accessible by members of that company. They have uses across all functions of a company, from accounting to marketing to management. Databases are essential to functions in any department of a business. In addition, database management systems are the key to making these huge databases practical and functional for businesses. This has been my presentation on databases, and I hope you learned a little bit. Thank you for listening.